Hey everyone, I'm Dionysis. Thanks for joining today. This is going to be a slow ride because we'll talk about like loads of different, very interesting things. And I have only run this presentation a couple of times, even though this is a topic that I'm very passionate about. It's something that we do at GWI, and it's very nice. So it's very exciting to talk. And it has worked very nicely for us, and I'm really looking forward to hear some of the horror stories, or how other people do these kind of things in other companies. All right, so apologies, I'll just mumble for a couple of more minutes just to give enough slack for people to join. Please raise your hand if you have any questions. We can either discuss things as we go along, or we'll have like maybe a 5 to 10 minutes Q&A in the end of this discussion. So in this kind of lectures, because we will talk about a myriad of things, it's always the case, how deep technical can you go? You can only focus on the high level stuff, or you can dive deep in the things that really make sense. And I think from my experience, you need to do something from both. So, someone who is listening to those things for the first time should be able to gain as much as someone who really came to this talk just to get some really deep insights that they may unblock them in the future. So what we're gonna talk about today. So we'll have some introductions, which we just did, and then we're gonna share some things about the state of DevOps in GWI, which is very interesting. And then we'll do a high-level presentation about infrastructure as code and Terraform and how we do things here. And then we'll introduce Atlantis. So Atlantis obviously is going to be the meat of this presentation. So we'll dive deep into this a lot. But for me, the most interesting thing is the last part, what the future looks like for us and for the industry, hopefully, in general. So a couple of things about me. My name is Dionysis Tsoumas. I'm head of DevOps at GWI. I'm here for like a year and a half now, and my background is software engineering, but I was always doing DevOps stuff. I'm now into a DevOps role for 5 or 6 years at this moment, and the DevOps team at GWI is relatively small for the rest of the engineering team. So we have around 60 or 70 engineers, and we plan to go to 100 at some point early next year, but the DevOps team is tiny. So yeah, this lecture is our journey through that, how we manage to scale in such a big engineering team with such a very small DevOps team. The challenge is how we have done this, some of the obstacles, what worked or what didn't work for us, and the way that we are moving forward. Before I start, obviously we're hiring. We have loads of interesting positions, and we have grown a lot, especially during COVID. We're fully remote, or you can come in the office if you like to. We have some very exciting and interesting projects, a very interesting product, and some amazing colleagues, very cool work ethics, and we're hiring back-end, front-end, and we are doing some very interesting stuff. If you're interested, get in touch, either myself or visit the website, and then we can take things from there. So DevOps at GWI, how we're doing things. So let's take a step back. Let's see history. So GWI, it's not an engineering company. Okay, so head of product, like lots of people, they don't know. For them, engineering department somewhere they're working on their own stuff, and this is fine. But for us, this means that when people start working on it, we focused on a team of contractors. Back then, we didn't have in Athens office. So people were contractors in other countries, and they could pick up their stuff, some brilliant engineers doing their work, delivering stuff, and that's it. So because we didn't have like proper teams, and the proper engineering department, it means that for DevOps to work and iterate fast and work very quickly to produce all the things that the product wanted, we worked with guilds. So this is something that's coming from Spotify. and naturally we had the DevOps Guild. And the DevOps Guild means that, and that's in the DNA of the company, that GWI's engineers need to know their DevOps stuff. So not everyone, but if anyone wanted, would be DevOps champion, and every engineering team should have one or more DevOps champions. And the DevOps champions idea means that the whole company could have a DevOps guild, and we would have a very small DevOps team that would work on the things that made sense, but mostly it would be there to guide the rest of the teams or guide the rest of the DevOps champions. And those DevOps champions, because of that, they were responsible for any DevOps related tasks that had to do for a specific team. For example, infrastructure, you want to create a new database, no problem. You wouldn't ask your DevOps guy, you would just ask your DevOps champion inside the team. And that DevOps champion would have enough knowledge to work with Terraform and permissions and everything to do this task for you. Maybe, you were the DevOps champion, or maybe, everyone in the team really liked DevOps stuff. So this is how DevOps things were doing in GWI for a couple of years ago. And this is still the case. So because of the way the guild worked, it really gave us the ability to work really fast. Okay, we didn't have many dependencies. You wouldn't have an outside team. You wouldn't have to worry about resources. The team was completely isolated, in a good term of isolation, to do its own things on infrastructure. They could use the technologies they wanted and stuff like that. And because of that, we managed to grow a lot very fast. We were splitting to, for example, if we would split and create a second team, no problem. We just, give a DevOps champion over there, someone who knew the way to do things, and then that's it. You scale. And in fact, we scaled so much that for a long of time, we were fine with one and a half DevOps people. At that point, DevOps, they were just putting the basics, and then everyone else was picking up tasks, and then they were doing things internally. Less than 2 people for a 30 or 40 engineers we had back at that time. That's great. Now, things are a bit different, even though the model is still the same. So we are 60, 70, maybe 80 engineers by the end of this year. And we have still a small DevOps team. It's not 2 people, 1.5, and now will be 5 or 6 people by the end of this year. Still a very small team comparing to the rest of the engineering department. And this is how we managed to scale. But I have mentioned, about engineers that were responsible to do their own infrastructure, and this is where naturally we discuss about Terraform. So I assume that if you come to this lecture, probably you know about Terraform. But either way, I'm going to spend a couple of minutes describing what Terraform is. So Terraform is, I think, now the default. Almost everyone is using it when it comes to infrastructure as code. And the idea behind this is that you don't have people just clicking through a UI to create databases, VMs, Kubernetes clusters, and stuff. Everything is through code, and we'll see what this means for us. Actually, it made a huge, it gave us a huge boost on the way we're delivering stuff. But obviously, Terraform is the way to move forward. And it's not, we'll talk about Terraform today, but every cloud provider they have their own solution. Terraform, it's open source, and this is what the community is using. But GCP, AWS, and Microsoft, all of them, they have their own similar approach to do managed infrastructure as code in the cloud provider. But we'll talk about Terraform today. And so what Terraform is doing in a very short sentence, it's, every cloud provider, they have their own APIs. So you want to create a new cluster, you just, hit the Google API with the attributes that you want, and then it will create. So Terraform is a high level, it's an abstraction layer on top of it. So if you want to create a Kubernetes cluster or a database, instead of pinging the API of the provider, you just write your code in Terraform. And then Terraform is responsible for keeping this API up to date. Okay, so Terraform is actually talking with the providers. In Terraform, you haven't worked on it. It's an amazing tool. Okay, it gives you like a whole view of how we are doing stuff. And in fact, GWI last year, like exactly a year ago, we had a whole daily workshop dedicated to Terraform. GWI and a few other colleagues of mine talked about certain Terraform problems. You can have a look, if you Google DevOps League, there are a couple of sessions, daily big sessions. And the last one was dedicated on Terraform. So it's a very good introduction about going from basics to really deep dive level on how we use Terraform. And this is how a Terraform resource looks like. All right. This the best practice is just a single resource, but you can see how easy it's to read it. This will create just a bucket in Google Cloud. And, you have a name. You just say the location, when it's going to be deleted, and the life cycle, stuff like that. So with 10 lines of code, maybe less than 10 lines of code, you have a bucket there, and then Terraform, it's taking, we'll see how Terraform looks like. But the idea is you have all your infrastructure in code with all the good benefits that we'll see they're coming out of it. In fact, when you use the Terraform CLI to create this resource, this is what Terraform will reply back to you. Terraform has a couple of options. The most popular one is plan, that will tell you what it will create, and then apply, where you apply all the resources. And anyway, I don't want this presentation to be about Terraform, but this is the way we were doing stuff. So someone was writing code, and then locally they would do Terraform plan. They would see what Terraform will say it will create, and then they would run Terraform apply, and then Terraform would actually go and apply this code. Then engineers would go back and open a PR, and then someone would review, and then they would merge, and then everyone would be happy. This is how we managed to work, okay? And it worked greatly for us. So again, every team, let's say that you want to create a database, you would do it either yourself or you would speak to your DevOps champion. They would create a Terraform resource, a database, you would open a PR. Actually, we have a GitHub repository called Infra. So you would open a PR in Infra, someone internally from the team will review. If there would be questions, someone would ping the DevOps would give their opinion, and then they would apply, the DevOps, like the team would apply. So everything would be taken care internally. So the team would apply, and then we'll close the PR, and that's it. And it worked amazingly well for us because teams were completely by themselves responsible for infrastructure. And this has obviously some great benefits and some downsides that, we'll talk about this in a bit. But because of this, we managed, no reason just to search for loads of DevOps teams and, have fraction. Everyone was a DevOps. And this is the idea of how we're doing things even today. So a couple of good things and a couple of bad things. So the good things is, everything was moving very fast, no fraction. Knowledge was shared across departments because people had to be knowledgeable about DevOps practices. And because, it's, all of those things, they didn't exist like 10 years ago. So, it's kind of exciting. And so people could satisfy their DevOps needs. And I've seen loads of engineers, migrating to DevOps positions or migrating to other companies because they will play around with DevOps tools as well. This is something that GWI had from day one. But we were, mostly would be moving very, very fast. So some of the bad things that, they came out with these practices is best practices went south because people, even though, they were feeling flexible and confident around Terraform, if someone, we didn't have enough DevOps people to review the PRs. So if someone would do something that it was a bad practice, people would copy paste this, across the board. So it was very easy because there were so many engineers working on the infrastructure for best practices to go completely south. It was also difficult to keep consistency. You wanted to do something, you want to upgrade Terraform version or any kind of upgrade. It was very difficult because you would have to communicate these changes across like 70 engineers, which was impossible. But the thing that didn't work for me, it was that DevOps were not the owners of infrastructure, which is good. This is what you want. You want everyone to be responsible for the infra, but I'm talking about the GitHub repo. So we weren't the owners of the infrastructure repo. So what I mean is like, if you want to add a check or if you want to take away some permissions, people were complaining. Okay, so the GitHub repo did not have a proper owner, which was a bit awkward, right? So this was bad. But there was some stuff that were really ugly as well. So infrastructure was fragile. And fragile, this is very awkward to say because it's still maybe it's also the case today, but when you give the engineers so big, like such a big power to do whatever they want, they are responsible for whatever they want, infrastructure is fragile, which means everyone could bring down anything. Okay, when you move so fast without very good code reviews, without people really knowledgeable what they're doing, it's also possible to bring down something. And when you scale so long, people may be very familiar around Terraform. In other companies, come here, bug, delete something from another team. You need to be very cautious on the permissions you give. But until our point, it was fragile. Things could go bad any minute. And also, this solution didn't scale. So, we had 15 engineers back then, and kind of was working. But would it work when we had 100 engineers? Things could be completely insane. But the most obvious, really, really bad thing is that people were running Terraform locally. So if you want to do any Terraform change, you were running things locally. Doing a plan locally, and then you would do the apply locally, and then the reviewer had no way to see what's happening. For someone would have to clone the repo and check out your PR and do a plan, and then it was very awkward. So most of the times because people were in a hurry, they were doing local Terraform apply, which means that it has no history. So if something was breaking, we had no way to know because there was no history. People were doing those changes in their local machines. But we also focus on the good stuff, okay, because these things let us scale for a few years very effectively. But we need to fix this. And this is where Atlantis comes into place. Atlantis, in theory, it's something very straightforward. And the idea behind it is that, why you would allow your engineers to run Terraform plan and apply locally. Let another service that runs in your cluster do this for you. And this is what Atlantis is doing. So Atlantis, in a high level, is something very simple. It's just a pod in your cluster, a service that is called Atlantis, and it's just listening to Terraform PRs. So if Atlantis sees that there is a PR in GitHub and it has Terraform changes, the only thing that it does is close those changes, does a plan for you, and then posts all the findings in a GitHub comment. If you give thumbs up, and you give it permission, it can run an Atlantis apply for you. It can apply stuff. So on a high level, what Atlantis is doing is it takes the Terraform plan and apply away from the local machines and puts it in GitHub. It runs in a cluster. Because of that, though, because it runs plans and applies and puts the outputs in comments, it gives us a ton of flexibility of how we can automate things on a better scale. And let's have a look about what I mean. So this is a couple of screenshots about what Atlantis is doing in practice. So this is a screenshot of a very simple PR that it just adds the simplest Terraform resource you can have, just a null resource. A null resource, it's nothing. It's over there, a placeholder, it keeps some data and stuff, but it's tiny. So let's say that we create a null resource that we call demo, and it's empty, and then we create a PR on it. Because this is a Terraform file, you can see it from main TF, the name of the file. Atlantis is listening to those PRs. And Atlantis sees the change, locally clones the repository and does a Terraform plan. And then it outputs in a comment in GitHub what it will actually do. In this case, we'll see, it plans just to create a null resource. So yeah, it uses the Atlantis bot and it says, this is what I will create. Straight away, we can see the benefits. Someone can go and review this kind of thing. Okay, right now you don't need to do this locally or, take the word of your colleague. Right now you can see what actually Atlantis will create for you. So you are a reviewer, you're Alice, you are a reviewer, you go there, you see the change, you see the code, you see what Terraform will actually create, and you give a thumbs up. You review, it's fine. Then the owner of the PR, the coder, instead of doing Terraform apply locally, it just let Atlantis do it. And that's very simple. You just go on a comment in GitHub and say, what, Atlantis, please apply for me. Atlantis apply. Atlantis is also listening for this, does a Terraform apply locally, and then it puts in a comment the results, and you see. So it's very simple, okay, in a high level. Atlantis is extremely powerful. You can do a ton of things with it, but by the end of the day, what it's actually doing is a local plan and a local apply for you. So it takes away the ownership of the engineers to massively weird, like in a weird case sense, play around in their local environment and do this somewhere that you can have access and properly monitor. Yeah, and then you can delete your branch. So let's see what we have done. If you remember from the previous slide, this is that was the issue. So best practices went south. Very difficult to keep consistency. DevOps not the owners of the infra. Infra was fragile. No local Terraform, no history, solution doesn't scale. Let's see out of the box which of those things Atlantis is solving from us. For the first few, it's very easy. Code review. Until that point, we could not do a code review because it was not obvious to the reviewer what Terraform will actually do. Because now Atlantis is going and it's pasting stuff in the comments, it's very easy, with a very simple look to go and see what will change. So code review completely solved from us, the best practices and the consistency. Local Terraform no history. This is coming again out of the box because comments track history. So if I'm wondering about something on my code, I can go and see in which PR this got implemented, and I can check the comments to see what Atlantis said, what changed, how we did things and stuff like that. So it's a very easy way to keep track of your infra, and it's coming for free out of the box. And because previously we didn't know how this will scale, but now we know because we can automate it. It doesn't matter if a user, we don't have to rely on him. It doesn't matter if he ran plan or apply or what he saw or what he thought he saw. It doesn't matter. Okay, this scales. Atlantis can take any PR and do plan and apply in a logical way that's exactly the same for everyone. It doesn't matter if you're using a different version of Terraform or you are upgrading and stuff. It doesn't matter. It works exactly the same for everyone. And this is what DevOps is about, right? It's about automation. But we have left out some of the very, very critical stuff. DevOps are not the owners of infra, and infra is fragile. Let's see how we can fix those couple of things as well. So Atlantis, we said high level, it's very easy, but it can be configured and fine-tuned a lot. So, and when I say a lot, I mean a lot. You can be very creative on how to restrict certain policies. But something that's very nice as well is that it supports Conftest. And we'll talk about Conftest a bit. Let's talk about the fine-tuning in the beginning. So let's say, let's take an example. In our case, we don't want engineers to mess up with IAM roles, GCP IAM roles. As an example, an engineer could go and assign himself an owner on the project, create a PR. Atlantis will say, I will give you ownership in everything in HWI, then your colleague can go and approve, and then it's going to be approved and merged. And suddenly you gave yourself like ownership without anyone figuring it out. We want to, because Atlantis is amazing, but at the same time it has flexibility to do whatever you ask it for. Okay, so we want to restrict these kind of things. In our example, we don't want the engineers to mess with IAM roles, which means we don't want the engineers to gain any additional roles other than what DevOps gave them to. Okay, so we just want engineers not to do this, only close group of admins. And we'll do this, there are many different ways to do this. We'll do this on the Atlantis side. So this is just 4 lines of Atlantis configuration. You say that, in the directory of the Terraform buckets, this is where the Terraform state lives, the GCP buckets, this is where the state is. We don't want everyone to have access. And you say this by saying, this PR will not be mergeable. Actually, you cannot apply. Someone needs to mark this as mergeable. And mergeable is an attribute that it's different on the different buckets. So, for example, for GitHub, mergeable means that if you have protected brands, not everyone can go and apply stuff. So it's a bit complicated. So again, you should say, you know what, this PR, if it touches this specific regex, okay, so if it applies code on this specific regex that has to do with buckets, treat this as a protected branch, okay? And protected branch means that not everyone can merge or apply, only people for a specific team. So, you know, can be the owners, can be specific group and stuff like that. So this is a very easy way with just 4 lines of code to restrict access to mess around with Terraform code from everyone else other than, you know, DevOps or some squad leads and stuff like that. And now let's talk a bit about Conftest. So Conftest, it's a very nice, you know, it's a utility that lets you write tests against structured configuration data. Conftest relies on the Rego language, which is coming from OPA, Open Policy Agent, for writing policies. And OPA, it's being supported natively by Atlantis through Conftest, but it's not, doesn't only have to do with Terraform, right? So this Open Policy Agent, you know, has its own language, which is it's easy. You know, you need to get the grasp of it, but anyway, it's easy. And the idea is that you write certain policies, and based on these policies, Atlantis can give you the way thumbs up, apply, or, you know, you cannot apply because there is a policy in place. I'm going to give you an example. This example is also the same as with a null resource. All right, so we've just created a PR with a null resource, and, you know, we say, you know, Atlantis, what are you going to create? And Atlantis said, yo, I'm going to just create this resource here. But there is a policy for null resources, because for some reason we do not want to have null resources in our state. Okay, so in the configuration there is a policy that says no null resource will ever be allowed. Atlantis says that this is what I will create, but then it throws another error saying, you know what, there is a policy against this, and, you know, null resources cannot be created. Cannot be created unless, you know, someone, you know, really approves this. So, you know, a specific team or specific group of people in order to approve it. So you see, if here someone tries to apply, Atlantis will fail. So Conftest, you know, some use cases about how can be used. You can be as creative as you want. You know, you can deny usage of a list of modules. So let's say I don't want anything other than either GWS modules or Google's modules, Terraform modules to be used. Anything else, you know, can be denied. This is how you do it. If you want to assert attributes, you know, I want every resource, Terraform resource, to have a name or to have a label. If it doesn't have a label, you know what, fail. Unintentional resource deletions. You can stop Terraform resources from being deleted, but it's not very nice. Conftest does this on a much better way. So, for example, if Atlantis says, yeah, you know what, I will create those 3 resources, but I will delete these 5 resources, Conftest can say, you know what, it's going to delete 5 resources, or it's going to delete more than 5 resources. Someone needs to have a better look. So request review from the DevOps team. And what's more interesting is, you know, you can prevent security risks. Like very often engineers, they can open, you know, ports to public, and, you know, or it's very difficult to catch those things straight away. That's fine. This is why we automate stuff, and it's very easy to automate this and add a much better code review for this kind of things. And this is only the start. Atlantis, you know, we have seen how it can use policies, either through Atlantis itself, through its configuration, but mostly through Conftest and with the open policy framework. You can be extremely creative. It doesn't only have to do for Terraform. It can also be for Kubernetes stuff. You know, you can check images, have the latest tag. You can be very creative. Okay, it's very interesting if you want to have a look. And something also a very nice combination of Atlantis is Atlantis and InfraCost. So InfraCost checks with your cloud provider and tells you how much the things that you will add will cost you. Like, so it's very often the case for a team, you know, just create something on Atlantis, and then when it passes, InfraCost tell you, you know what, this VM will cost $300 per month. or you have upgraded this machine and it's going to be that much more expensive. It's a very good combination for teams or for people who have ownership over their infrastructure. Okay, and this is only the start. Let's see what the community give us in the future. So let's take a step back. What we have in DWI is engineers, they are owners of their infrastructure. Okay, if they say we need this, then we need this. It doesn't matter. All right. So what we have here is every team is responsible for their own infrastructure, but you need to be cautious, okay? Because with great power comes great responsibility, and sometimes when people are in a hurry, they are not that much responsible, right? So the DevOps champions, besides WI and the DevOps Guild, ensures scalability. It doesn't matter how many teams we are, if we make sure that each team has a DevOps champion or people who are very passionate about DevOps practices, then it scales, because the whole company is very DevOps centered. Sorry, so it's very good around DevOps practices, and we're very passionate about what we're doing. But in order to make things work for us and not having a lot of downtime, we need to ensure certain strict policies or very good code reviews. And this is why Atlantis and Conftest and OPA policies help us, because we don't only need to rely on best practices or best efforts. We know that people are very cautious about what they're doing, but at some point you don't know what you don't know. So you can't know everything, and this is why you need very strict policies in there in order to mitigate the damage that can be done by giving all this flexibility to engineers. And this again let us build the DevOps team with scalability in mind. So what we are doing is mostly developing the toolset, giving support, having loads of workshops, and implementing those things that make us scale, right? So we don't work a ton with the engineers. That's it. I think just in time, maybe we'll have like 5 minutes for questions and stuff. Thanks for participating. We have talked about a ton of time, so it depends about a ton of things. So it depends on your familiarity around Terraform or DevOps or Atlantis. But for us, it has worked great, right? And there is, there's no look back. That's it. Any questions? Anything that you want me to talk about a bit more? If you have questions, you can also get in touch in my mail or in my LinkedIn. Again, we have lots of positions open, and we're very passionate about what we're doing. We have some very exciting problems to solve. So yeah, happy to chat about anything you may come up. All right, no questions. So let's get 5 minutes back for our time. Thanks for joining. Thanks for your time. I hope you enjoyed it. If you want to have a look, or if you're wondering about how these things scale, they do scale. They have some very interesting projects. It's very challenging, and those things are kinda new. So I don't think there's an easy way. You can see how other companies, they manage to make this work, but I think every company is different. I think personally that if the company is very DevOps oriented, then it can scale. If you are cautious about policies that you use and you try to automate as many things as possible, then it scales amazingly well. Anyway, that's it. Thanks for listening to me mumbling for like almost 40 minutes. And if you have any questions, get in touch. Thank you again. Enjoy the rest of the event.